Gagan F property. Diagonals bisect each other in trapezium. Diagonals are bisect each others in trapezium. Take this trapezium figure. Gagan see better. This is the trapezium figure. Diagonals are bisect each others. Here it is the diagonals are, is it not equal only? Okay, not bisect only. So that's why not equal and not bisect only. So that's why this statement is, what's that? No. Is it satisfied? Not satisfied only. So that's why no. And next G property. Diagonals are equal?
No.
Diagonals are, is it equal?
No.
No, it is diagonals are all not equal only. So that's why this is also not satisfied only. So it is no. Next H. All sides are equal in trapezium. All sides are, is it equal? All sides are, is it not equal only in trapezium. So yeah, this property is also not satisfied. So that's why it is no. And next I. Each angle is right angle in trapezium. Each angle is the right angle? No, each angle is not right angle. Sum of the interior angles of parallel sides and unparallel sides are supplementary in trapezium. So that's why, yeah, each angle is not 90 degrees only. So that's why this property is not satisfied only. So it is no. So next J property. Diagonals are perpendicular to each other in trapezium. Diagonals are not perpendicular to each other. Point O point. So that's why this property is not satisfied. So it is no. Okay, are you clear? Trapezium, it's over. Trapezium quadrilateral is over. And next we'll go to the parallelogram. Properties. First properties. These all are is the, what's the parallelogram, rhombus, rectangle, squares. These all are is the quadrilaterals. I will explaining with set squares in the geometrical box. Have you seen any time in the geometrical box Gagan sai set squares?
Yes.
These two are the set squares. I will explaining. Okay, with set squares. These all are the quadrilaterals properties. I will explaining with the set squares only. Okay. Yeah, first one. Only one pair of opposite sides are parallel. See the parallelogram figure Gagan side. Set squares in a geometrically box. Okay. This is the right angle set square, and this is the isosceles triangle only. Okay. Yeah. How many we needed in that these set squares? Right angle set squares is 4, and this is also 4. Isosceles triangle is also 4. Set squares are we needed in this these topics. Today I will explaining one. Okay. But these all is 4 sets are not available. So sample I will explaining this type of models only. Okay. Sample I will take this one only. Same models of these 4 set squares. This is all are the 4 is the all are the right angle set squares. All are the equal. All are the equal set squares. All are the equal 4 right angle set squares. And next these all are the 4 isosceles set squares. Yeah, these models, sample models. Okay. Yeah, originally I will take these 4 only. First parallelogram. I can say first property. Yeah, first one. First property. Only one pair of opposite sides are parallel.
Yes.
Parallelogram. One pair of opposite sides are is parallel. Yes. Yeah. Let us take 2. See better neatly. 2 set squares. Right angle set squares. It is formed a parallelogram. Okay, is it a parallelogram?
Yes.
Yes, it is a parallelogram. Okay, are you clear? This opposite, both pair of opposite sides are parallel. Okay, these sides and these sides is parallel only. And diagonals are, is it equal? In these
No.
parallelograms, diagonals are is not equal. This is the length diagonal, this is the what's the short diagonals only. And next, in these parallelograms, opposite angles are, is it equal only? Okay, parallelograms opposite angles are, is it equal? And diagonals are not equal, bisected to each other in parallelogram only. Okay, one by one property, is it satisfied or not? In parallelograms, one by one you write it only. One pair of opposite sides are parallel. Yes, one pair of opposite sides are parallel only. So it is a satisfied. So you write it S only. Okay, are you clear? And next one, say B1. Two pairs of opposite sides are parallel. In parallelogram, two pairs of opposite sides are parallel. Yeah, two pairs of opposite sides are parallel only.
Yes.
This property is satisfied?
Yes.
Yes, it is satisfied. So that's why yes.
Yes.
Write it the S only. Next, C property. Opposite sides are equal?
Yes.
Opposite sides are equal?
Yes.
Opposite sides are parallel and equal also. So that's why here it is the this side and this side equal, this side and this side is also equal. So that's why this property is it satisfied? Yes. So you write it the S. Okay, are you clear? Next one. D. Opposite angles are equal. In this parallelogram, opposite angles are, is it equal? Yes, opposite angles are, is it equal? This angle is equal to this angle and this angle is equal to this angle only. So opposite angles are, is it equal only? So this also satisfied. So S. And next E. Adjacent angles are supplementary. Adjacent angles are, is it supplementary? Yeah, suppose this is a B, C, D only. So angle A plus angle D is equal supplementary or is equal to 180 degrees. Otherwise angle A plus angle B is equal to 180 degrees. So yeah, this F property is also satisfied only. Okay, are you clear? This and this adjacent angles are supplementary. So this property is satisfied. Okay, are you clear? So yes. If you satisfied, you write it the yes only. Otherwise, it write it the no. F only. Diagonals bisect each others. Diagonals are bisect each others in parallelogram gagan side. Bisect each others only. Diagonals are bisect to each others. Say yes. Okay. Diagonals are bisect to each other, but diagonals are not equal only. So intersecting, diagonals are intersecting at point O. Here it is the OA is equal to OC. Okay, OB is equal to OD only. So diagonals are bisected to each others. Next is the G is the diagonals are equal. In parallelogram, diagonals are is it equal?
No.
No, it is not equal only. So it is not satisfied. So that's why it is no only. Okay, are you clear? Next, H only. All sides are equal in
No.
parallelograms. All sides are not equal only. So all are only opposite pairs of sides are, is it equal only? But all sides are not equal in parallelogram. So that's why this property is not satisfied. So it is no. And next I. Each angle is a right angle.
No.
In parallelogram, each angle is not a right angle. Sum of the two adjacent angles are, is it equal to 180 degrees. But each angle is not a right angle. So it is a statement is
No.
not satisfied only. So that's why it is no. And J only. Diagonals are perpendicular to each others in parallelogram.
No.
Diagonals are not perpendicular to each others only. Bisect each others, but they are not perpendicular to each others only. Diagonals is not perpendicular to each others. So that's why this is also not satisfied only. So it is no. And next rhombus. Let us take the rhombus only. First property. Only one pair of opposite sides are parallel.
Yes.
This property is satisfied or not? Let us take the rhombus only. How many we needed set squares we needed in this rhombus? 4 set squares are we needed only. Yeah, this is the rhombus. How many set squares are needed? Right angle set squares, 4 set squares are we needed only in rhombus. Okay, yeah, this is the rhombus only. In this rhombus, one pair of opposite sides are parallel. One pair of opposite sides are parallel. Is it satisfied or not?
Yes.
Satisfied. These opposite sides are parallel only. Okay, look at this one. Parallel are equal. So that's why this are satisfied only. This property is satisfied. Next one. Second one. Two pairs of opposite sides are parallel. Two sides are opposite parallel. Yeah, look at this figure. Two pairs of opposite sides are parallel only. So that's why this side and this side, two pairs of opposite sides are parallel. Why it is satisfied this one? It is also parallelogram only. Rhombus is also parallelogram. Parallelogram means is the two pairs of opposite sides are parallel or equal only. So it is also rhombus is also this property is satisfied only. Are you clear? Are you understood? So it is satisfied. Say you write it the S only. Next, opposite sides are equal.
Yes.
Third property. Opposite sides are, is it equal in this rhombus? Yes. Opposite sides are equal. Opposite sides. These sides. Okay. Opposite sides. Sides are parallel or equal only. So that's why this is also S. And next D. Opposite angles are equal.
Yes.
Opposite angles are, is it equal? This angle, and this also equal. Okay, are you clear?
Yes.
Opposite angles are, is it equal? So this property is it satisfied? Yes. You can write it the S only. Next, E only. Adjacent angles are supplementary. In rhombus, adjacent angles are supplementary. Yes, adjacent angles are supplementary. Angle A plus angle D is equal to 180 degrees only. So these adjacent angles equal to 180 degrees. So are supplementary. So this property is satisfied only. So it is S only. Next, F. Diagonals bisect each other.
Yes.
Diagonals are bisect each others. Diagonals are bisect each others only. In this diagonals are bisect each others, perpendicular and bisect to each others only. Okay. Diagonals, these two diagonals are intersecting at right angle and bisect to each others. This side is equal to this side and this side is equal to this side only. So yeah, this property is also satisfied only. So it is S. Next, what is the diagonals are equal? Diagonals are, is it equal? In this rhombus, diagonals
no.
are is not equal only. Why it is not equal? Yeah, this is the diagonal. This diagonal is very short. This vertical diagonal is very long only. Then comparing of this horizontal diagonal. So that's why, yeah, this is the diagonals are, is it equal? No, it is not equal only. So it is not satisfied. So it is no. And H, all sides are equal?
Yes.
In rhombus, all sides are, is it equal only? So that's why.
Yes.
S. And next I. Each angle is a right angle.
No.
Each angle is a right angle?
No.
No. In rhombus, each angle is not right angle only. Adjacent angle. Sum of the adjacent angle is 180 degrees. So that's why, yeah, it is not satisfied only, this property. So that's why it is no. And next J. Diagonals are perpendicular to each other.
Yes.
Diagonals are perpendicular to each others. Yeah, diagonals. These diagonals and these diagonals is perpendicular to each other only. So that's why this is the S. This property is satisfied. So yes. And next rectangle. Okay, are you clear? Are you understood? Yeah, this is the rhombus. It's over. And next rectangle. let us take the two set squares. Set squares. This is the rectangles. Okay. This is the rectangle. Yeah. Next, first property. One pair of opposite sides are parallel.
Yes.
Yes. One pair of opposite sides are parallel. Why it is parallel is it is a parallelogram. Rectangle is also parallelogram. So that's why one pair of opposite sides are parallel only. So that's why this property is satisfied.
Yes.
Yes. This is a rectangle shape. Yes, rectangle shape only. Next, second property. Two pairs of opposite sides are parallel.
Yes.
Two pairs of opposite sides are parallel. This also and this also. Okay. And this also. Two pairs of opposite sides are parallel or equal. So that's why this property is satisfied. Yes, satisfied. So write it the S only. Next, see, opposite sides are equal. Opposite sides are equal.
Yes.
Parallel and equal only. Opposites are parallel and equal. Okay. So that's why this property is satisfied. So yes. And next, D. Opposite angles are equal in rectangle. Each angle is how much? Dragon side, tell me the answer. How much? Each
90
angle
degrees.
90 degrees only. So each angle, all angles are is the 90 degrees only. So all are the angles are is it equal angles only. So opposite angles are equal is given in this D property. So is it satisfied? This opposite angle, this angle and this angle and this angle is this angle. All are the angles are is it equal only. So opposite angles are is also equal only. So this property is satisfied. So you can write it S. Next, E. Adjacent angles are supplementary. Adjacent angles are supplementary. So these two are either these two. Sum of these two angles is equal to 180 degrees.
Yes.
90 plus 90 is equal to 180 degrees. This property is also satisfied. Say S. Next one. F. Diagonals bisect each others in rectangle.
Yes.
Is it correct or not? Look at this figure, Gagan Sai. Okay, rectangle figure. Diagonals bisect each others. Diagonals, this diagonal and this diagonals bisect to each other at point O point. Okay. Here it is a O point and bisect to each other. Yes, diagonals are is it equal and bisect to each others only. So that's why here it is this is property is also satisfied. Yes. And next, diagonals are is it equal?
Yes.
In this one, yes. Diagonals are is it equal? Okay, diagonals are is it equal? This diagonal and this diagonal. Both diagonals are is it equal only? You already it's over. This figure, okay.
Yes.
Diagonals are is bisect to each others and all are the diagonals are is it equal only. Each angle is 90 degrees only. Okay, are you clear? Next, H1. H property. All sides are equal?
No.
In rectangle, all sides are not equal only. Only opposite sides are equal only. So that's why all sides are not equal only. This side equal. But this side, all sides are mentioning there only. So that's why all sides are not equal only. So this property is not satisfied. So it is no. And next, I. Each angle is right angle. Each angle is right angle, Gagan say? Yes. Each angle is right angle only. All are the angles are right angles only, 90 degrees only. So it is a S only. And next, J. Diagonals are perpendicular to each others. Yeah, diagonals are bisected to each others. Diagonals are equal but not perpendicular only.
No.
Okay. So here it is this not satisfied only. So it is no. Okay, are you clear?
Yes.
Next, square. Next property is square quadrilateral. So let us take this one only. Isosceles set squares. How many we needed in this quadrilateral? Here 4 set squares are we needed. Isosceles set squares are we needed only. So how to form a square with these 4 set squares. How many set squares are we needed? 4 set squares are needed. How to form a square? Shape this shape only. Okay, this is the square. How to arranging of this one? This like only. Okay, all are each set squares are same. Arranging with this one, get a square form. We get it. Okay, are you clear? I will explaining this. All are the properties are explaining with set squares. Geometry box. These set squares are using in this problem. Okay. Yeah. First one, square. First one, only one pair of opposite sides are parallel.
Yes.
In squares, only one pair of opposite sides are parallel.
Yes.
Yes. All one pair of opposite sides are parallel or equivalent. So this is satisfied. So S. Next, second one, two pairs of opposite sides are parallel.
Yes.
So why it is S? Yeah, this is also, it is a square is also parallelogram. Two opposite sides arrow marks. Whenever the two opposite two double arrow marks is gave, yeah, that is the what's the square only. Already learned this one only. It is also parallelogram only. So two pairs of opposite sides are is it parallel only. Okay, are you clear? So it is satisfied. Yes, it is satisfied. And next, C property. Opposite sides are equal. In your square, all sides are is it equal only. So opposite sides are parallel or equal also. So that's why this property is it satisfied or not? Yes, satisfied only. So S. And next D. Opposite angles are equal. So opposite angles are is it equal? This angle and this angle, this angle, this angle. All are the angles are is it equal to 90 degrees only. All are the angles. Each angle is 90 degrees only. So that's why opposite angles is also equal. Okay, all are the sides are equal and all are the angles are also equal only in square only. So that's why this the property is also satisfied. So it is S. And next E. Adjacent angles are supplementary. Adjacent angles are is it supplementary? Yes. Any two adjacent angles. This side adjacent angles and otherwise these sides of adjacent angles. Any two adjacent angles are is it supplementary. 90 plus 90 is equal to 180 degrees. So that's why this property is also satisfied only. So that's why it is S. Next, F. Diagonals bisect each others. In square, diagonals are bisect to each others and diagonals are perpendicular to each others only. Okay. All are the sides are is it equal and all are the angles are so equal and diagonals are is bisect to each others and diagonals are is it equal and diagonals are perpendicular to bisect to each others only. Okay, are you clear? Diagonals are bisect each other's only. So this side length is equal to this side length and this side length is equal to this side length. These two diagonals are is it equal diagonals and perpendicular and bisect to each other's only. So this property is it satisfied only. So it is a
Yes.
S. It is S only. Next, G. Diagonals are is it equal?
Yes.
In this square, all diagonals are is it equal only. All means is the two diagonals are is it equal only. So it is S only. Are you clear?
Yeah.
Here this side and this side diagonals are is it equal. And next one, next property. All sides are equal.
Yes.
All sides are is it equal. All sides are is it equal only. In square, all sides are is it equal. All angles is also equal. So that's why is the what's the H property is it satisfied. So we can write it S only. It is satisfied. You write it the S. And I. Each angle is a right angle. In square, each angle is a right angle. Yes, each angle is the right angle only. In square, all are the sides and angles are is also equal. This angle and this angle, this angle. Oh, each angle is 90 degrees only. So that's why this property is also satisfied. So it is S. Okay, are clear? Next J. Diagonals are perpendicular to each others in squares. Diagonals are perpendicular to each others only. Okay, these diagonals and these diagonals is the perpendicular only. Bisect of each others only. This side is equal only. This side, and these sides and these sides all are the equal only. Bisect of each others. Diagonals are perpendicular and bisect of each others only. So this property is satisfied. So S. Okay, are clear? Yeah, this is the squares only. Are you clear? Are you understood? Yeah, this is the second bit. All problems and solutions is over. Yeah, this law is over. And next this problem solution is over. And in this different types of quadrilaterals is the one is the this is the kite. Okay, let us take the two perpendicular set squares. So how many set squares are we needed to form a quadrilateral, a kite quadrilateral? By using the set squares, I will explaining the kite also. But here the second question is not there only. Just in your different types of quadrilaterals, yeah, I will explaining with this set squares. I will explain. So let us take the right angle set squares. Two right angle set squares. Let us take it. How many set squares are we needed? Two set squares are we needed only. How to form a kite? Yeah, this is the kite. Okay, how many set squares are we needed in this kite quadrilateral? Two set squares are we needed. By using of these two right angle set squares to form a this one only. Yeah, this is the kite. I will explaining the kite properties with set squares. Okay, kite is the two pairs of adjacent sides are is it equal only? Okay, adjacent sides are is it equal? And next what's that? Here this opposite angles are is it equal only? Okay, angle B is equal to angle D only. Next diagonals. Diagonals is the this one only. This diagonal, one diagonal, and this is the another diagonal only. Okay, diagonals are is it equal? Diagonals are is it not equal?
Yes.
Why? Because here it is this side is the short length, this side is the very big one. So that's why these diagonals are is not equal only. Okay, diagonals are only one diagonal perpendicular and bisect to each other only. Only one diagonal is perpendicular to bisect to each other. So this is the this diagonal is perpendicular of this one. For example, let us take these names is AC and BD only. So AC is perpendicular to BD. This is the perpendicular one. Okay, perpendicular and bisector of opposite angles are is it equal? And this angle is it equal only? And diagonals is not equal only, and bisector only, perpendicular. Okay, and next OB is here it is the BO is equal to OD. So here it is this side is equal to this side only. Okay, only one diagonal perpendicular, only one diagonal are perpendicular and bisector of each of one another only. Okay, are you clear? Here sides are is the opposite, two pairs of adjacent sides are opposite pairs of equal are parallel only. So that's why that is its over. And angles is opposite angles are is it equal? Angle B is equal to angle D only. And next what's the diagonal? Diagonals is not equal only. So diagonals are bisect and perpendicular bisect of each others only. So here it is the OB is equal to OD. Okay, are you clear? This is the kite properties. It's over. Are you clear? Yeah, this, yeah, today is my class, it's over. Are you understood of the today my class, Gagan side?
Yes.
Yeah, exercise 8.1, only 2 questions. It's over in today my class, it's over. And today is my class notes. This is the my class work notes, Gagan side. Okay?
Yes.
8th chapter quadrilateral introduction 8.1. This is the my class work notes. Are you understood today class, Gagan side?
Yes.
Yeah, this is the class work notes. A theoretical part. This is the exercise 1 and 2 questions and problem solutions. It's over in our textbook only. This is 8.1 to 8.3. This is the class work. My notes. It's over.
Okay.
Okay. Are you understood? Are you any doubts today my class?
No doubts.
No doubts. Okay, today is my class is over. Say thank you. Have a nice day. I hope this video is helpful for you. Like, share and subscribe my channel. Say bye.